and it makes sense to continue doing things with Mars after the first landing. So the idea here is to use a commission strategy to get to that long-term plan and answer the question, now that we have Mars, after we land, what do we do with Mars? So what I'd like to cover on this topic is why do a long-term plan for Mars, and how do you do a 200-year plan for Mars? And that includes, pardon me?
Go about 10 and say the rest will take care of it.
Yeah, that's one way to do it. So I'm going to be showing you some ingredients that go into a 200-year plan, and talk about the return on investment, and then talk about the commission strategy for doing this, how it would work, and the characteristics and advantages. And then talk a little bit about getting started and what's been done so far and what are the next steps. I'll take questions and some feedback at the end. If you have any questions about clarity or what I said, by all means raise your hand, but I'd like to ask you to hold your comments and questions till the end so we can get everything done. And feedback, I'm very interested in Mars Society folks telling me what they think of this whole idea. It could be extremes, anything from here, put it right in here, in a trash can, or I'm from the office of the president and he'd like to talk to you tomorrow morning. And so either one of those extremes, I'll accept his comments. You know. In the latter case, I'll have to check my schedule. So, okay, so why do we do a long-term Mars plan? Well, there are about 4 reasons I can think of. One is to avoid the lunar experience with Apollo, where we went to the moon and we did the goal, which is we got there on time and everything, but we had no follow-on credible and budgeted plan after that. There was a follow-on to the Apollo mission, but it was not budget justification. And then the other thing is to make the first landing a step to a direction to go forward and not just a end point in itself. Thirdly, we need to make a long-term plan to determine a business case and help set the course by a credible authority. And then lastly, to integrate major thrusts which are diametrically opposed. Like we just heard from the last speaker, you want to do science first, and then you do want to do maybe some terraforming or settlements or whatever, but a lot of these major thrusts are diametrically opposed, and so it would be very advantageous to figure out how to integrate those major activities. And finally, and this is maybe the most important, and that is we want to have a long-term plan available after the first landing in order to support near-term funding for the first landing, because if there is justification for follow-on, there is more likely to be money up front to do the initial missions. Why do a 200-year plan? Why not 20? Why not 100? Or why not 500? Well, as you know, planetary missions take a long time. From the planning stage to the accomplishment stage, it depends on planetary alignments and trip times and many other things which work into that. Also, a short-term goal for Mars is to get a self-sustaining base on the planet so you can do a lot of science to start with. And that is outlined in this book. I think you're familiar with this, The Case for Mars by Dr. Robert Zubrin. And this book contains a lot of information about getting a self-sustaining base and how you would do that. And it turns out to be maybe a couple of decades to really get a good base going. Because you want to change locations, you want to do some testing, you want to find better resource locations on the planet. So this book, if you take a look at it, has good information about doing the base. Thirdly, any long-term plan might involve, or most likely would involve, terraforming Mars to make it as Earth-like as possible. In Dr. Zubrin's book, he has a lot of information on terraforming, and it turns out to be not so hard. It's kind of easy. The problem is, though, it takes decades and maybe even centuries to do the terraforming. And finally, much science needs to be done before terraforming begins. Obviously, the scientists and the terraforming operators will have a little conflict if they want to work on the same area. The scientists would most likely say, stay off of Mars until we're done. So, and that, a lot of information about that is also outlined in Dr. Zhu's book. So how do you do a long-term plan for Mars? Well, one way is to envision the end result, or the end case that you want to arrive at. What's the final conclusion? And then take that envision and march it backwards by 50 or 20-year segments and find out what are the intermediate goals and what are the near-term goals. And along the way, you can identify certain technologies that would be nice to have that are maybe not available. You can identify other missions that we need to have on Mars to make the next step up on the getting Mars to what we want to have it in the 200-year time period. Also, the plan would need to have change flexibility. Any plan that's 5 years also has to be flexible to change. So you can imagine the changes and the flexibility needed for a 200-year plan. And finally, you can take all the schedules in that plan and multiply by 2 to get something more closer to reality. Budget 2, multiply by 2. In my career, I happened to work for NASA for a time at the end of the 70s. And I was the Advanced Studies Manager for Planetary Systems. And in that time period, we did a 5-year plan, a 10-year plan, and a 20-year plan that went from 1980 to the year 2000. And the 5-year plan was just to do budgeting and what new stars could be fit into the wedge and so forth. And the 10-year plan was to identify technologies that were on the horizon that could be useful in 5 or 10 years. And the 20-year plan was for the things that we desire. We desired to go to Comet Halley. We desired to get an asteroid sample return, and many other things. We desired to put up a Hubble telescope. So some of the things we were actually done, but many things took a little bit longer than 20 years. Matter of fact, if you maybe realize that just a week and a half ago there was a launch for the OSIRIS-X mission, which is sending a spacecraft to an asteroid called Bennu that will pick up some soil or samples from that asteroid and bring them back to the Earth by the year 2023. That's 43 years after our plan was devised. So multiply things by 2 and you got something closer to reality. Now, what are the ingredients of a 200-year plan? Well, in my mind, there are 4 major thrusts that need to be done if you want to terraform Mars and have it as a living planet. And one is to have allowances for science explorations. And scientists want to keep the planet pristine and uncontaminated as long as possible. They can do a lot of science all over the planet. And then you want to integrate the terraforming operations, and that's going to take a long time, even after the science is complete or near complete. You would start this, and that would take, as I mentioned before, decades and maybe even centuries. Then you want to integrate the settlements on Mars. Where do people live? Where are the stores? Where are the stores? How do you get transportation and so forth? And speaking of that, you want to integrate a Mars infrastructure, which includes managing water, oxygen, food, fuel, energy, and materials, and industry. How do you make something? What if you need an aspirin? Call the planet Earth for the next delivery. So you have to be able to manufacture a lot of things on Mars that you are doing on Earth. There are other thrusts, maybe not as major as these, but other minor thrusts that I would call minor, that have to be accounted for, such as legal ramifications. Who decides what land is owned by who? Governance, how do they govern on Mars? The whole commercial end of it has to be a thrust that is accommodated on Mars. The ingredients of this 200-year plan, I'm a little bit cut off to the left here, but the ingredients to this plan have to include a lot of Mars research platforms that are ongoing, such as the International Space Station, obviously, continuing on to 2024. And platforms such as this organization is sponsoring, as the MDRS, that's the Mars Desert Research Station, and one that'll come online next year, which is the Flashline Mars Arctic Research Station. And there's some more information about these in the backup slide in my handout. But probably the most important thing to have in this plan is the budget justification. As I mentioned in the Apollo program, there was no follow-on budget justification. So that's one of the main things that have to be in this plan to continue Mars activities after the first landing. So the question is, did I miss a slide here? Okay, oh yeah, budget justification. So the budget justification has to do with comparing the cost of going to Mars and operating on Mars with what you get back for it, the return. Now the cost, I got some recent data that indicates that the first landing cost is going to be around $30 billion. That's roughly the value that's estimated by NASA and also by Dr. Zubrin. The cost to achieve self-sustaining Mars, that's the big question. What do you want as a self-sustaining Mars? And that's the cost that goes out to a point where you meet those 200-year goals. And that could be done a lot sooner than 200 years, or it could not be done at all. So I estimated that just for talking purposes, put a factor of 10 on that first landing cost, and you got something that maybe is close to what we would have to get Mars to a point where we would be satisfied. And by satisfied, I mean not spending a lot of money from Earth on Mars. Let the Martians take over. So there's a lot of return on investment avenues. Probably one that everybody agrees with is multi-planet human survival. So to have another planet that's just pretty much like the Earth hanging out there is probably worth at least 100% of that 300 billion, maybe many, many times more. Just the spin-off technologies that go into that could be used on Earth, just like the Luna program, could be worth probably over 100% of that total cost. Human health medical advances, obviously a very powerful, valuable return on your investment, most likely over 100% of the investment. Resources for Earth, continuing solar system exploration, who knows, but maybe 3 digits of percent. Knowledge about our solar system and universe in the long term, probably over 3 digits of percent in return. And inspiring youth and uplifting human spirit, same thing there. And other, including commercial uses, maybe more prevalent than, or more earlier than some of these. Also a 3-digit percent return. But notice that most of these, aside from the commercial, are all non-real or returns that are not dollar equivalent. So they're intangible. So the investor or the the taxpayer could say, where is my return? If I put my taxpayer hat on, I said, fine, go to Mars, but what's in it for me? And you can say some of these, but to a truck driver, that doesn't really make any sense or have any value necessarily. A big return can be the consideration that Mars could be a new world, as America was to Europe. And Mars has a moat around it. It's called space, and it's right now, it's called environment. You don't go to Mars because you can't live there right now. So Mars is isolated, and it can be a new frontier, and it provides all the things that a new frontier would provide: creativity, challenges, innovation, and so forth. And Mars could be a place for human advancement, for society advancement, and a place for a new kind of government. Mars provides a place for thousands of other things just like this. So these are all intangible, but it's easy to see there's a lot of value there. But the question is there something more immediate that the current taxpayer would say, what's in it for me? And so we could think about some immediate returns, but in considering all these intangibles, ROI is kind of an understatement, don't you think? I mean, there's so much value there in time that the return on investment is a little bit like an understatement. So there are some immediate opportunities to get value out of Mars. And one is the youth of the world today could identify a vision for what Mars might be like in 200 years. And the youth, can give you more vision than you could ever imagine. And so using this vision, it might be some clues as to what might be a good thing to provide for Mars. The youth would we would get engagement in STEM from the youth. We would get youth engagement in space exploration in general, in Mars, and in their own future. And they would also, like I say, provide interesting concepts that we could never imagine. So that has value. I think every parent in this room would agree that inspiring youth has a lot of value. You don't have to put a dollar value on it. So a question is, how do you get to a plan that provides all this? And one way is using a commission approach, a Mars Planning Commission. What I think would be very helpful is to have an Augustine-type commission. The commission would conduct required studies. They would utilize experts in all areas. They would be totally independent of NASA, independent of commercial companies, and any other organization that would benefit from their results. And they would report to the president. The commission accommodates international involvement. So they would go off and contact or have appropriate contacts to accommodate international interests. And the commission is funded by the executive branch and can in part use international resources. So the commission would be headed by a very reputable industry leader like Bob Stevens, who used to be the Lockheed Martin president and CEO. And I happen to know Bob from earlier engineering work before he became president. And I know that he is a very honest, straight-shooting kind of guy, and if he always looks at all the parts of what his business is what is the business case for that endeavor. And if there's no business case there, he won't play around with it. It's out. And so I would trust Bob Stevens if he came back and said, we've looked at this Mars thing, and yeah, it makes sense to go there and set foot on Mars and have a grand humanitarian milestone in human history. But after that, kind of settle it out like the moon and don't spend any more money on it because there's some showstoppers there that'll kill you. Or a Lori Garver, who I don't know as well, but she used to be assistant NASA administrator, and she's now retired from that area and working in other areas, but I think she would be a good one to do head of this commission. And maybe an astronaut who is well known and independent, retired from NASA, and could look at it in a very unbiased way.
A retired Russian.
A retired Russian? Well, maybe. Maybe he could serve on the board. The commission would set up its own goals, operations, schedules, and budgeting. They would utilize experts, like I say, they would utilize NASA expertise, but not report to NASA. They would maybe utilize other science organizations like the National Science Foundation or National Research Council, and they would obviously utilize research on the ISS, and as I mentioned, they would utilize research platforms that are starting to become many, and they would get the results from those studies, not fund them, but get the results, and then incorporate those results in their plans. They would target a first plan to be available by the year 2020. I think it could be done if it gets any kind of start by next year, or even the year after that. And they would review it and adjust it every 5 years. So the plan in 2030 might look totally different than the plan in 2020. That's because you learn new things and you get new technologies and you have new ideas and so forth. But the idea here is to get it started. So the commission should consider the science major goals, levels of terraforming. You could terraform to a certain level and take a break, stop, or get more technology and then go farther. They would provide solutions to perceived showstoppers, which I think there would be many as you get into it. They would, the total cost of achieving a first self-landing settlements is what they would concern themselves with, but they would not identify how to do that. They would be concerned with the ROI levels over time, and there are levels, and it would be concerned with the strategies for the funding after the first landing, and identify immediate return on investment avenues. The commission should not be concerned with details on how to get to Mars for the first landing. That's been done 6 times from Sunday, and it'll be continued to be done. So this commission is not worried about how to get to Mars. This commission is not a flight plan, it is a planet plan. Details of how to achieve near-term funding, like I say, those kind of details are not the business of the commission. Political differences, obviously, it would be a bipartisan commission. And other distractions that will come up, and they'll have to just fend them off. I have started to push this, and a couple of things that I've done. I've sent some letters to the current presidential candidates about a month ago. A one-page letter, just summarizing this whole idea on one page. Of course, I haven't heard anything from either one of them yet. I don't expect to, but I do expect that maybe if they have a good staff, they will file it away appropriately, and when they get around to actually considering their space program and their objectives and that, they might come across this and they might kind of feed it in there. Even so, I would, I'm also in the process of contacting some congressional staff members that are supporting some science and technology committees. But probably soon, maybe by early next year, I will be attempting to contact some offices in the executive branch, if they still exist, on science and technology. And there, I expect to have some kind of an interaction. And then the idea, though, is that it can be also a global strategy with the International Space University and the UN. I have contacts in both areas, and I might poke around there, or let it, if I get some traction from this country alone, or a congressional activity, then they could take over those kind of thrusts to get more interaction on the international scene. And I'd also like to consume feedback from the Mars Society. I'll be here all 4 days and 3 nights. So if you don't have a chance to talk to me today, you can get to me in the hallway or somewhere, and we can talk to any kind of idea that you might have. So in summary, unlike Apollo, a Mars program can grow. So Mars has the resources, a little more gravity, a lot of potential for doing things with the atmosphere and terraforming and so forth that you can't do with the moon. An in-place plan can promote near-term budgeting, and that's very important. If Congress knows there is a credible plan to do things with Mars after we land, then maybe the budget to land is not that bad. It's justified. And a long-term plan promotes a long-term focus. And the way to get anything done long-term wise is to have a focus at the end. And so that's what this plan would provide. And for expected Mars settlements, a very long-term plan is needed to integrate the diverse desires. As I mentioned, 4 major thrusts and a lot of minor thrusts that need to be integrated. An independent commission can provide results. Political actions have just begun, as I mentioned. Feedback is desired, and there's a vision that's beyond 200 years. And my vision is that, yeah, we can terraform Mars and live on it, and one day, maybe 200 years from now, Mars will be like out there. It'll be green, not rusty color. And so in that shirt sleeve environment, there could be a lot of science done. The people on Mars would not be shipped from Earth, as we have to do to start with. By the way, one thrust is to get population on Mars. And there's a couple ways to do that, but efficient way is to have people born on Mars. Then they are Martians, and those Martians would start to evolve a little differently than people on Earth, a different environment. And Mars will continue to be terraformed like the Earth, but not quite like the Earth. So the humans and the planet will become convergent, so that it would be a very efficient and highly valuable planet to live on. The advances in science and all fields could you just use your imagination beyond 200 years. And my kind of closing thought on that is that they will become so advanced in the science world that one day they may come back and save the Earth. So I'd like to take now questions and feedback. I wrote some of these things down here that I covered in some ways, but we could talk about others. And there's some backup slides in the handout that contain added information.
We have 4 minutes.
4 minutes?
Yes.
Oh, it's quarter to 2.
10 minutes slow.
Oh, that's 10 minutes slow. I'm sorry, I didn't know that. Okay, a couple questions. Yes.
Okay. You mentioned possibility of forming, new forms of society and new government. I would recommend dropping that. At the risk of sounding like the cynic that I am, if the 20th century hasn't taught us anything, when people start talking like that, start counting your ammunition, because it's going to lead to disaster, and sooner rather than later.
Well, and I would add to that, the Martians would take care of their own government. Is that what you mean? Or, I mean, they would form what works for them and not worry about people from Earth trying to help them out. Yes?
I think the commission idea is a great one. I worry that, granted we're at the Mars Society convention, but that it needs to be perhaps more broadly focused on space activity generally. And, because I think that would,
Well, you mean
again,
they would
leave
be
Mars in isolation,
so that commission would be involved in asteroid exploration.
Yeah, exactly.
I would argue about that because I want the focus to be on Mars.
Okay.
And they could form an asteroid commission if they want to, or a side commission from that commission. But I think if they could get something going on Mars, that would be great. But in the back.
You talked about building flexibility into your 200-year plan, but how can you possibly try to predict where technology is going to go past the next 20 or 30
Exactly,
years?
exactly. As I mentioned, I did a 20-year plan for NASA between 1980 and year 2000, and there was not 60% of it did happen, but it took more time. And the answer to that is we review and adjust the plan every 5 years. So there would be an addendum or a new revision every 5 years, and that would accommodate new technologies that come along, and that continues every 5 years to the year 200. I mean, the 200-year point. Yes?
Yeah, I think it's quite conceivable that before that 200 years approaches, we'll have first contact.
We'll have what?
That's an example.
First contact.
Oh, with who? With who?
We may get a lot of help.
Okay, well, that's good. That's
That
a,
would be great.
that would be great. That would be a major plan revision at that point. That's right. You had a question?
Yeah, comment. In your whole scheme here, I don't see any place where creativity is nurtured or encouraged. I think you need somebody who's a little bit wild and crazy to bring in some fresh new ideas. I was a part of a think tank at one point, and one of our members actually was a science fiction writer.
Oh, okay, there you go. Well, that's a good point. I'll take that into consideration. The idea is for the youth to come in and to add to that creativity.
To think
Yes.
outside of the box.
Yes. Okay, maybe one more question? Okay, I think we, did you have a question back? Okay. So, okay, very good. If you have any more questions or comments, please grab me in the hallway or wherever you can find, and I can be glad to discuss it.